What's up, everybody? So we're officially past the halfway point in our trimester. Today we're going to learn about where does light come from? Where does any amount of light in the entire universe come from? But we're going to kind of narrow that down a little bit. Our do now today is for you to open up jump rope, and on your worksheet that is for today, you're going to fill out the table. If you have a 0 for anything, you may have completed that thing, but you just didn't click submit. If you don't click submit, I'm going to give you a 0 until you submit it, and then I'll grade it. You can complete work with a 0. If you got a 0, you can resubmit it. I will regrade it. If you have a 1 or 2, I will also regrade that. I even leave you comments to be like, this is how you fix your work. You can make those corrections. You can resubmit it. So I'll show you what that looks like. That is this page here. This is your score. And then again, what can you do to make this better? Like if you have 0, you just got to complete it. If you got 1 or 2, you got to look at my comments. Cool. So our survey results. Our survey results said the following. Generally speaking, this is based on the majority of the survey. We like the simulations. Those have been going well for us. We want more practice problems. That's what I've noticed. Everybody's like, ooh, we need more practice. Like, you only asked me a couple questions, Murray. That's the nature of having a really small number of classes. It's kind of hard to do a lot of practice problems, but I will change the class based on what people want. So, because of that, we're going to do more practice problems. Speed of class, not too fast, not too slow. Going about right, which is cool. And the majority of what people wanted to learn about next, that final survey question, bioluminescence. So we see a couple things here, and we're going to take a second, and you're going to pause and you think about what do you see is a play on words, obviously not spelled that way. What do you think, and what do you wonder? There's things you can observe, there's things you can think about, and there's things that you might want to ask questions about, wondering. So you're going to pause, take like 3 minutes, answer those questions to yourself. There's no place on the worksheet for you to answer these. You're just thinking about these. Okay, so these things we're going to learn about them, but you're going to learn about them. You're going to do your own like little self-guided learning and breakout rooms if you're rewatching the video for instructions. And we're going to use this simulation. This simulation is part of this worksheet. So you got bioluminescence. You're going to watch a YouTube video that's got my favorite narrator, David Attenborough. And you should definitely read this top part. That'll help add some context to this. Then you're going to click this link here for the simulation, which will bring up this page here. On this page, if it doesn't load, make sure that you, like, there might be a thing that says, like, click to enable Flash. You want to enable Flash if your computer's like, I'm not running, or you just say, like, a white screen for the most part. There's going to be, like, a thing that says, like, click to enable Flash, do that. You've got a set of guided questions where you're going to play with it, make some observations. You're going to make some comparisons to the last model. And these really important questions are at the bottom, number 10 and number 11. The level 4 question, I might go over if we have time. So during class, this is a 25-minute exercise. So if you're like, wow, Murray, this is taking me 25 minutes, then good. It's about how long it should take you. So pause, use this, work through it. And so don't listen to this part yet if you haven't finished. I'm going to go over our important questions here. Number 10 and number 11. So make the electron jump from orbital to orbital. When, right? What causes the box to use the word emitted, and what causes the box to use the word absorbed? So we're talking about this box up down here, right? This is wavelength of absorbed photon. And if I go from orbit 2 to orbit 1, we see something shoot out. It says wavelength of emitted photon. Well, let's make it jump up again. Let's go back to 2. When it went up, it says absorbed. When it jumps back down, it says emitted. So, because in the previous problem, oh, wrong page, because in the previous problem we're talking about my answer to number 9, which I haven't filled out here yet, which will be filled out here. We're talking about when an electron bounces from orbital to orbital, when it goes up orbitals from its first orbital to its second orbital, it needs to absorb A photon. It needs to absorb light. Photons are just little particles of light. That's where all the light in the world is coming from. It's coming from photons and only photons. And if you want to go up if an electron ever wants to go up, it needs to absorb photons. See, we just move from this photon, or sorry, from this energy level to this energy level. We move from this orbital to this orbital. It absorbs more photons. Look, I'm going to go up again to the fourth one. It's absorbing again. But let's see, let's jump all the way back down to 1. Boom, just shot out 1. Now it says wavelength of emitted photon. So the general trend that we're noticing here is, in the big takeaway, is that if you want to go up, you must absorb photons. Anytime you go up, they absorb photons. That's why you see on the left-hand side of the screen photons coming in. But if you jump out, look, boom, a photon shoots out and the electron jump back down. So in the first video, we saw the fish with a glowing lure on the head. It's emitting photons. That glowing little lure on the top of its head, in order for the atoms inside of that to emit photons, what has to happen to the electrons inside of those atoms? Those electrons must go up in energy level and then back down. So they get some energy in, they get a photon in, and then if they want to release a photon, if they want to emit light out into the water, their electrons need to go from higher energy levels, higher orbitals, and they need to jump back down to lower ones. That would be like a glowing beam of light right there. Every time you see one of these little squigglies coming out, boom, that's a little glowing beam of light. Okay, so there's the level 4 question. I probably won't go over that, won't have time. But right now is when there'd be a break. Album of the Week's Harlan Alondra. We have a new learning goal here. I can analyze and interpret data about the stability and change of electrons and photons. So on your worksheet, make a prediction. What is a possible assessment of this learning goal? What could I ask you to do that would be an assessment of this? Be some sort of quiz, be some sort of little mini check for understanding. What could I do to quiz you on this? Pause and give yourself a second to do that. Okay, now here is going to be a time for different vocabulary. So we've got Murray's definitions here. This is where you're filling this out. I've given you electrons, nearly massless subatomic particles found in orbitals. You already know that. Orbitals, you also know this. Orbitals are rings that hold electrons. What is new about it is what I've underlined. Each ring has a different energy level. So, because they have different energy levels, well, what are they? So if you are close to the center, you are low in energy. Black has the lowest energy. If you go up one, green now has a higher energy. And pink now has the highest energy. Because you're going up and up, you're going further away from the nucleus. Gotta take a second for this new vocabulary, ground state. When all electrons are in the lowest possible energy orbitals. This is in the ground state because the electron is in the smallest, it's in the orbital that's closest to the nucleus. If it moves out, it's no longer in the ground state. This is a stable atom. Pause and get that down. An excited state. When one electron is in a higher energy orbital, this is an unstable atom. So, right now we're in the ground state. Let's jump up. This is now an excited state. Because the electron is in a higher energy orbital, one that's further away from the nucleus, if you want to go back down to the ground state, boom. Going from the excited state to the ground state, it just jumped back down and it shot out a photon. Which might ask you, lead you to say, what are photons? Photons are particles of light that get released when electrons go from high energy orbitals to low energy orbitals, when they go from the excited state to the ground state. Pause and get that down. Now's a little time to test ourselves. So it's going to be a first or second. It's either going to be the image on the left or the image on the right. May as well make this full screen now. So which, first or second, which matches the words at the bottom? So we have electron here, mass 1 or mass 0? Pause. It's mass 0. Electrons have no mass. They're pretty much close to massless. Cool. First or second, orbital. Look at where the arrows are pointing. So this points to one of the rings, so this is an orbital. Electron. This one points to what is in the orbital, the electron. You might say, like, Murray, this one was pointing at the orbital too. It's like, no, it's pointing at the electron in the orbital. We got to pay close attention to that. Ground state. Go back to your definition here. Remember, ground state is when the electron is in the lowest energy orbital. The low energy orbitals are close to the nucleus. Boom, right here, close to the nucleus. Excited state. So which one of these is in the excited state? So if you go back to your definition, that's when when one of the electrons is not in the lowest energy orbital. This is the lowest energy orbital right here. It's close to the nucleus. This one is a higher energy orbital. The electron is no longer in the lowest energy orbital. This is now in an excited state over here. Which of these is stable? Going back to your definitions, it says that ground state atoms are stable. This is a ground state atom, so it's stable. Unstable. So you might be saying like, oh, it's a little easy now because like if this is stable, that means this is unstable. Why is this unstable? This is unstable because the electron wants to hop back down to become a stable atom. So you got breakout rooms right now. So right now you are going to be working on this part here, your definitions. You're going to use my definitions, and you have to rewrite all of these definitions in your own words. This is what I'm going to assess for your note-taking learning goal for today, is this part right here, creating your own definitions. That should take 6 minutes. So we've got a practice exit ticket here. Pause and take like 4 minutes to think about these 3 questions. We have a ground state atom, and it's going to become an excited state atom. What happens to the energy level of the electron? Does it increase or decrease? What happens to the stability of the atom? Does it increase or does it decrease? Is a photon emitted or absorbed? Sorry, absorbed or emitted? Pause and think about that. It should take you like 4 minutes, so really think about these questions. Okay, and our answers to this. The energy level of the electron increases. It starts in a low energy orbital, goes to a high energy orbital. The stability of the atom decreases because ground state atoms are stable, excited state atoms are unstable. A photon, in order to go from the low energy orbital to the high energy orbital, needs to be absorbed. It needs to get more energy to get to the higher energy. We now have a different process here. It's an excited state atom going to a ground state atom. This is where you are going to do your worksheet. This is where you have your questions, and you're going to answer those questions. This is what I'm assessing for learning goal 1.3. And then you're done for the day. Later, folks.